This is TWiT.
I stole this app cap. Steve Gibson sent me an email last week, after the show last week, after Security Now, saying, oh, you got to try this new game. I love it. I'm loving it. And he's not on till later this afternoon, where he'll probably talk about this game. So, Steve, I'm sorry. I'm going to steal this from you. It's called Circuitry, and it is a logic. I like it because it's a game. It's a fun game. It's a very challenging game. But you also will learn boolean algebra, logic gates, and digital circuits. Yes, that's how in fact, you're going to see the TWiT logo very early on. So like a lot of these games, you know, you've got problems to solve, and then there's a playground that you can create circuits with. But let's just start. I've gone farther at home, but I just thought I'd start at the beginning because it gets pretty hard pretty fast. A logic gate is an electronic circuit device which does a Boolean operation. Boolean's logic, and or true, false. Linking wires in circuitry allow these signals to be passed on from the outputs of the gates to the inputs of other gates. That sounds complicated, but here's the idea. This is an AND gate. So the way AND works in Boolean algebra, the output is true only if both of the inputs are true. The output is true only if both of these are true. So what we're going to do is we're connect these and connect these. Then we're going to check answer. So have we figured this out? Yep. So if they're both false, it's false. If one's true and one's false, it's false. But it's only true. Oh, actually, an AND gate. If both are false, it says. Oh no, that's right. Yeah. So it only is true if both are true, and it worked. You ready for the next one?
Yeah, I'm down.
That seemed pretty darn easy, right? But this is going to get a little bit harder. We've got two AND gates. In the previous problem, actually 3 AND gates. We wanted the output to be true when the first and second output were true. Using 2 AND gates, can you construct a circuit which outputs true when all 3 inputs are true? How do we do that?
Oh, dear.
Oh, dear. Well, I think here's how we do that. We're going to say this is going to output true only if both of these are true, right? Let's disconnect that from this and put this in here. Now, if we connect the output of there to that and this, now think about what's happening here. If these are both true, this is going to output true. That line will be true. If this is true too, that line will be true. 2 trues, and we should get a true. This should test it.
If it's wrong, will we blow up?
Yes,
okay.
But it's not wrong. Now, so far, oh, by the way, by doing this, I've unlocked an AND gate, which you might know looks a little bit like the TWiT logo. We'll get to the TWiT logo in a little bit. All right, now we got a 3-way OR gate. This gets a little bit harder. Using 2 OR gates, connect them so the output is true if any one of the inputs, A, B, or C, is true. So that's how an OR gate works. When you connect A and B to this, if either of these is true, A could be false or B could be false, but they can't both be false. If either of them is true, we'll get a true coming out that end. But we want to, and this is analogous to what we did with the AND gate. We want to add a 3rd input. So now, if any one of these is true, does that make sense? Let's try it and see. Oh, yeah. That's the last of the easy ones.
Wow, so
it gets harder. We're going to make a NAND gate. It gets harder.
This.
Isn't it fun? And
Circuitry.
So you're learning a few things. You're learning Boolean logic, true, false. But you're also learning what these circuit diagrams mean, and you're learning how to build a logic circuit. I love it. It's free. It's easy at first. You're not, and you might look at it and say, "Well, wow, there aren't very many problems." Don't worry. There are plenty of problems when you get to the end of it. I do hope that he adds more problems in the end. This is a really great. And there's a whole thing about circuitry. Rather about the app that you can learn more about it. I'm very impressed, I have to say. I think that they've really done a great job.
There's playground mode as well.
Yeah.
That's where things get really interesting.
But you have to unlock, in order to do that, you have to unlock these. And look at, so I've unlocked a button, a light, or an and. So I have some things I can do, but you'll want to get through all the problems to have all the possible circuits.
I love this.
It's free. It's free and it's fun. I really have to say, and you actually are learning something. I think any kid in high school, Actually, I bet you a middle schooler or a smart kindergartner could probably.
It says age 4 and up.
Yeah, with a kid, you'd probably want to spend some time as the parent with a younger kid.
Yes, spend time doing it with them, which is awesome. I love it. It reminds me a little bit of Snap Circuits. Do you remember that?
It's exactly that.
Yeah.
Except it's on the iPad.
Yes.
It's kind of the same idea. Yeah.
Yeah, Snap Circuits. I mean, my kids had those.
That was a
like
physical.
5,
Yeah,
6.
it was a physical version of this. Yeah.
Set
the outputs to be equal to a NAND B. That is. So what does a NAND gate do? Make the output signal false only when both inputs are true. It's a negative AND. It reverses it. So let's see. So this is a regular AND gate. Make the output signal when both inputs are true. So with a regular AND gate, now we know that this line's going to be true if they're both true. So it'll output a false. Oh, look, I even got a green light. Let's see. Yeah.
So you lit that up.
I lit it up, baby. It's getting harder and harder.
Lit.
Not using a NAND. And on and on and on. So thank you, Steve Gibson. I'm sorry I stole your thunder, but I figured people who watch Security Now probably don't watch iOS Today and vice versa. So I hope that everybody who watches Security Now doesn't tell Steve.
I'm going to email him right now just because.
I'm not doing any more because it's too hard now.